Hello, so today we are going to do another problem from this week's contest 309. So this problem is the longest nice subarray. So we get an array of numbers that consists only of positive integers. And we can say that a subarray of numbers is nice if the bitwise end of every distinct pair of elements in that subarray is equal to 0. And here distinct, just that the pair, the two elements are in different positions. And so that's the definition of nice. But we want to return is the longest nice subarray in the array. Yeah, including of length 1. So if you take a look at this example here, this subarray is the longest possible nice subarray. And if you take a look, you can do 3 and 8. If you convert 3 and 8 to binary and end them, you will find that it's equal to 0. Similar thing for 8 and 48, and then 3, 48. So every pair, the end is 0. And so we return the length, that's 3. If you try a lot longer subarrays, you will find that they are not. We will get a pair that is different than 0. Yeah, so that's the problem. Now, how can we solve it? Okay, so how can we solve this? So one idea here is that, well, as soon as we know that as soon as we find two numbers, maybe let's call them A1 and A2, such that the end operator is different than 0, then the window that contains both A1 and A2, or the subarray that contains both, is no longer valid, right? And so, but as long as we have elements that such that every pair is equal to 0, we can proceed. We can continue expanding our window, because what we are after is the longest subarray, right? So what this insight gives us is that maybe we can do a sliding window technique, right? Which means here we'll start with I and j both in position 0, right? And then we will keep expanding our window with j until we reach a place where this condition of equal to 0 is no longer valid. So when we find different than 0, then we need to shrink the window, right? So that's what sliding window, what we need to find is basically when do we expand and when do we shrink, right? So in our case here, so keep expanding as long as array is nice, or subarray is nice. Subarray here is from I to j, and shrink as long as it's not nice. So pretty straightforward here. Now the problem becomes, how do we determine quickly if it's nice or not, right? So nice means every pair, right? For every pair, maybe let's say k and l, their end should be equal to 0, right? So the easiest way to do that is just to keep to have one number, maybe call it used, and this number would have a 1 for every place in all the subarrays that has a 1. So what do I so we need some kind of data structures to keep track of the ones positions that are used, so that we don't have to check all the numbers in the subarrays already and check if for every pair the end is equal to 0. So we need a way that we can do that faster. So the way to do that is actually just, as I said, keep track of this used variable, and this used here would have 1 in every place that all the elements in the subarray in the window, so let's call them AI in window, have 1, right? So if you have, let's say, maybe the numbers, the representations of the numbers we have in our window, let's say maybe they are like 1, 0, 1, and then say 0, and then 0, 1, 1, 0. Okay, it needs to be valid, so yeah, something like this. Then in this case, let's say it has these two numbers, and in this case used would have 0 here because no 1 is in that place, there is 1 in this place, 0 and 1, there is 1 in this place, and 1 and 0, there is 1 in this place, right? So it would have a 1 in every place that has a 1 in all of the numbers. Which means in this case, if we have a new element, so let's say this maybe was like some x1, x2, x3, right? And this maybe was our x1 and this was our x2. Now when we are looking at x4, we don't need to check x1 and x4 and x2 and x4, right? We can just check used and x4, because if there is a 1 with used and x4 that in the same place, then we know the subarray with x4 is not valid. We don't need to check with every pair. We can just check in used, because used is a combination of all the ones in all of these subarray so far, right? So that's the idea here. Now one thing becomes, okay, so if used and x4 here in our case, so we are looking at this subarray, so this is our current window. If this is equal to 0, let's say maybe our x4 is like 1 0 0 0, then it would be 0, because they don't share any 1 in the same place. If we do like this and we do AND, this here would be 0 0 0, so it's equal to 0. So if we are in that case, then our window is still valid, so we can expand it. Let's say maybe our array here has more numbers, so we can expand our window. But what if it's not the case? What if maybe our x4 is something different? Let's say our x4 has maybe 0 0 1 0, so it shares a number 1 in this position. Then this means that if we do the AND, we'll have 0 1, we would have 0 1 1, so this is used. If we end it with x4 0 1 0, then we'll get 0 here, 1 here, so it's different than 0, right? So different than 0. So what happens if it's different than 0? That means we need to shrink our window, because the subarray here is not nice, right? So we need to remove this x2 here, we need to remove it and shrink our window, right? Because maybe the one that is shared between used and x4 came from x2. So if we remove x2, potentially we may get a nice subarray again, right? Because we want to be able to expand again and see if we can find the longest subarray, a longer nice subarray, right? And so how do we remove an element? We can use XOR, because why can we use XOR? First, because if you take any elements, let's say maybe y, and XOR it with y, with itself, you will get 0, right? So since we have, this is the x2 and x3 and x4, if we XOR with x2 again, then we will cancel x2 from used, right? And so let's say since x2 is this here, so if we take 1 1 1 and XOR it with x2 0 0 1 0, then we'll end up with 0 1 0 1, because XOR, if it's the same place has ones, it becomes zeros. So you can see this is actually just x1, so it's this after removing x2, right? And so the way to just summarize what we saw here, to shrink, what we do is we just say used XOR, or we can say used equal to used XOR nums of I, because remember I is the start, and this is j, right? So if we shrink, we want to advance I, right? And so that's why we do XOR with nums at position I. Sorry. Okay, so we know the operation shrink, what do we need to use? And how about extending our window? Well, to extend, what we said is we just need to include the new one in this, in used, right? So we need to just OR it. Basically, let's say we had used equal to maybe something like this, okay? And we have a new x4 maybe equal to 0, 0, 0, 1, 0, 0, right? So we just need to OR it. Now we would have 0, 1, 1, 1, and then 0, right? So now we have 1 in all of the places in this place. So now we need 1 here as well. Yep. So now we have 1 in all of the places for each. So to extend the window, we just add the value 1. And so to extend here, what this would mean is that we would do used, or the number at position. How do we extend? We said the far end is j, right? So we need with num just j. And so now we know the operations we need for our sliding window. And now the only thing to do is on each iteration that we extend j, we need to check if we have the best window. And so to check that, we just take the max with best. And what's the window size? It's just this is the window I to j. So to get the size, it's just j minus I plus 1. And so that's what we can use here, j minus I plus 1. Yeah, and the rest is pretty much just the usual sliding window technique. You would have I and j, and then you will fix I at the beginning, and then keep extending as long as you can. And once you can't, shrink and pretty much return best at the end. And that's pretty much it. So yeah, let's code this idea and make sure it passes test cases. Okay, so let's implement the solution that we just saw in the overview. So what we need is first we need just something to keep track of the length. And then we need best to keep track of the best we've seen so far. We need used to keep track of the number, the places where we have 1. And so we just use a number and do binary operations. And we need the start of the window. And all of these start out as 0, right? And now we will go try to extend the window, right? So we would take g from 0 to n. However, if basically window not nice subarray, then we need to shrink the window. And so that's what we do here. Keep shrinking the window until we get a nice subarray. So to do that, we'll do while. So when is the window not nice? It's when we find 1 in 2 places in used and in the number at position j, right? So if here there is a 1 shared in the same there is a 1 in the same position for both, which means basically this is different than 0, then we need to shrink the window. And to shrink the window, as we said, we just need to XOR with the element we want to remove. And so what is the element we want to remove? It's the start of the window, which is I. And so nums of I, and then we need to increase our I because we moved the start of the window to the right. Shorten this to just be XOR with nums of I, right? Okay, so now when we exit, that means it's nice again. The subarray represented by used is nice again. And so here we need to advance the window, right? So expand the window, which means basically we need to include the number at position j, right? J is the rightmost index of our current window. And this we can do also like this. And now we need to take the best, max of best and j minus I plus 1. Yeah, so this is the size of the window. And then at the end, we can just return best. Yeah, and that's pretty much it, right? So sliding window, shrink if we need to, expand if the subarray is still nice or valid, and then return the best size. So if we run this and let's submit, and that passes test cases. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.